Voyager spacecraft. We will discuss a basic functions of instruments that were used in Voyager spacecraft, so stay tuned till the end of this video. Voyager instruments that makes it successful to observe our solar system are 1. Terminal blanket. The blankets protects Voyager from extreme heat and cold in deep space, helping to maintain warm, stable operating temperature. They also protects Voyager's components from Metroid. Impacts. 2. Cosmic ray subsystem, CRS. The CRS looks only for very energetic particles in plasma and has the highest sensitivity of the 3 particle detectors. Very energetic particles can often be found in the intense radiation fields surrounding some planets, like Jupiter. Particles with the highest known energies come from other stars. The CRS looks for both. 3. The golden record. The Voyager message is carried by a phonograph record, a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. 4. The high-gain antenna, HGA. The HGA transmits data to Earth on 2 frequency channels, the downlink. One at about 8.4 GHz, 8,400 million cycles per second, is the X-band channel and contains science and engineering data. The other channel, around 2.3 GHz, is in the S-band and contains only engineering data on the health and state of the spacecraft. S-band has not been used since the last planetary encounter. 5. Infrared interferometer, spectrometer, and radiometer. The iris actually acts as 3 separate instruments. First, it is a very sophisticated thermometer. It can determine the distribution of heat energy a body is emitting, allowing scientists to determine the temperature of that body or substance. Second, the iris is a device that can determine when certain types of elements or compounds are present in an atmosphere or on a surface. Third, it uses a separate radiometer to measure the total amount of sunlight reflected by a body at ultraviolet, visible, and infrared frequencies. 6. Imaging Science Substation. The ISS is a modified version of the slow-scan Vidicon camera designs that were used in the earlier Mariner flights. The ISS consists of 2 television-type cameras, each with 8 filters in a commendable filter wheel mounted in front of the Vidicons. One has a low-resolution 200mm wide-angle lens with an aperture of f3, while the other uses a higher-resolution 1500mm narrow-angle f8.5 lens. 7. Low-energy charged particles. The LECP looks for particles of higher energy than the PLS, and it overlaps with the cosmic ray subsystem, CRS. It has the broadest energy range of the 3 sets of particle sensors. 8. Magnetometer. Although the MAGI can detect some of the effects of the solar wind on the outer planets and moons, its primary job is to measure changes in the sun's magnetic field with distance and time, to determine if each of the outer planets has a magnetic field, and how the moons and rings of the outer planets interact with those magnetic fields. 9. Plasma substation. The PLS looks for the lowest energy particles in plasma. It also has the ability to look for particles moving at particular speeds and, to a limited extent, to determine the direction from which they come, photopolarimeter. The photopolarimeter subsystem uses a 0.2 mm telescope fitted with filters and polarization analyzers. It covers 8 wavelengths in the region between 235 nm and 750 nm. 10. Planetary radio astronomy and plasma wave antenna. 2 separate experiments, the plasma wave subsystem and the planetary radio astronomy experiment, share the 2 long antennas which stretch at right angles to one another, forming a V. The PWS covers a frequency range of 10 Hz to 56 kHz. The PRA receiver covers 2 frequency bands from 20.4 kHz to 1300 kHz and from 2.3 MHz to 40.5 MHz. 11. Radioisotope thermoelectric generators. 3 RTG units, electrically parallel connected, are the central power sources for the mission module. Each RTG is made up of an isotopic heat source, a thermoelectric converter, a gas pressure venting system, temperature transducers, connectors, a heat-rejecting cylindrical container, and bracketry. The RTGS are mounted in tandem, end to end, on a deployable boom as part of the MM. 12. Shunt radiator and optical calibration target. The target plate is a flat rectangle of known color and brightness, fixed to the spacecraft, so the instruments on the movable scan platform, cameras, infrared instrument, etc., can point to a predictable target for calibration purposes. 13. Ultraviolet spectrometer. The UVS is a very specialized type of light meter that is sensitive to ultraviolet light. It determines when certain atoms or ions are present, or when certain physical processes are going on. The instrument looks for specific colors of ultraviolet light that certain elements and compounds are known to emit. Subscribe Eclectic Minds Hub for more interesting video.